Hi everyone. This is our first class, and I hope all of you are doing good. Okay. Before I start the class, let me just tell you a few things. Just a second. So, basically, we will be discussing in this particular session. We will be discussing few questions which were already there in few gate previous branches. But since we have only covered, like I can say just an introduction of linear algebra, and just like 3 4 lectures have been passed. So that's why I will not be taking the questions related to the advanced concepts which are like rank and other concepts. So, uh, so in this particular session, we will be discussing some basic questions which already appeared in GATE previous years in some other branches. I have not taken computer science or DA questions because I want to give them those questions as practice questions, and maybe most probably those questions might already been solved in the lecture. But still, if some questions are left, then I will put them as practice question. Once you practice, then we can discuss it later on. Okay. So now, since this is our first class, we will be conducting very regularly live classes for CSE and for DA both. Okay. And the purpose of the live class is mostly, okay, I can say the purpose of the live class is not to cover some content or not to cover the theory thing, because mostly the theory part is already covered in the lectures. The purpose will be either the doubt discussion or the practice questions or something like this. Okay. So some revision or maybe some summary lecture, something like this. But we will be having regular live classes. Okay. So let's just start the class. Okay. So this is from all the branches. Okay. So let's see the first question. This question is not from Gate PYQ. I mean, after that I have Gate PYQs, but this particular question is just some MSQ question, but it is not a Gate PYQ question. Okay. So let's just solve this question. So what they are saying, consider the system of linear equations Ax equal to B, where A is M cross N matrix and B is a vector of Rm. Okay. Which of the following statements correctly describe the possible number of solutions of the system? If B is not a linear combination of columns of A, okay, then Ax equal to B has no solution. So since this is MSQ, there might be multiple correct. So you can just tell me whether this is true or false. Okay. So what about the option A? You can write like this: A true. Okay, like this you can write. Okay, so that I get to know later on that you are talking about which option. So if you want to say something, you can say something like this. Okay, A true, something like this. Okay, so basically you are saying A is true. Yes, that is true, because if B is not a linear combination of columns of A, okay, then Ax equal to B has no solution. This is 100% true, right? Okay. Now let me just quickly explain that why this is true. Because if you remember, if you remember that we have something like this. See, this is this is a matrix A, okay, and this is X. Now this B is basically how we get this B. If you remember, let's suppose this is A1, one of the column, this is A2 another column, and this is A3 another column. Okay, and let's suppose this is anything. Okay, maybe 1 2 3. Okay, so can you tell me what will this be? This B will be, if you remember correctly, then let me just tell you, this will be 1 into A1 plus 2 into A2 plus 3 into A3. So basically this B is a linear combination of columns of A, isn't it? I mean that must be the linear combination of columns of A. So that's why if they are saying that B is not a linear combination, then you don't have any solution. Yes, that is true. I mean B have to be the linear B is always a linear combination of columns of A. If it is not a linear combination of columns of A, there is no way by using any X you can get this B. Okay. So is there anyone here who has not understood this A? I mean, I'm assuming that you have already watched the lectures. Given that you have already watched the lectures, I'm asking you. Okay, if you have not watched the lectures, then probably you can watch the lectures. Then you can come again. But if you watch the lectures and still you have not understood why this A is correct, let me know. Anyone who has watched the lectures and still have not understood why this A is correct? No, right? Okay, so everyone understood that. Okay, A is correct. Okay, now let's just go to the option B. What this option B is saying? So A is correct, right? So if B is a linear combination of the columns of A, okay, and the columns of A are linearly independent, then Ax equal to B has a unique solution. So they are saying if B is a linear combination of columns of A, so this is A, this is X, right? This is B. If it is a linear combination, that's good. And columns of A are linearly independent. Okay, if they're independent, then you have unique solution. So if it is a linear combination, then yes, there's a solution. But if they're independent, linearly independent, then unique solution, right? So that's what we already know. And I think there's a flow chart here that if the columns are linearly independent, and yes, then in that case it is a unique solution. Obviously, you don't have to remember this. Is there anyone here who can make this flow chart, okay, without even looking at it? Suppose if I ask you, Suppose if I ask you that B is linear combination of columns of A. Okay. Yes or no? If I say yes, if I say no, can you tell me at the no side, can I say unique solution, infinite solution, no solution, something like this? Can you tell me what should I be writing here? Immediately tell me. Then no solution, right? Okay, great. So there are many students who are commenting no solution. It's really good to see. Okay, I think almost everyone has commented no solution. Okay. So yes, then in that case there is no solution, right? Okay. Now you know, and you can hopefully make this flowchart. That's very easy. Like if there is a linear combination, then if they're linearly independent, then infinite. Oh, sorry, unique solution. If they're not linearly independent, then infinite solution. You know this, right? Okay. Now let's just quickly do the other options. Okay, without further wasting any more time. So B is true, right? What about option C? C is saying if B is a linear combination of columns of A and columns are linearly dependent, then Ax equal to B has infinitely many solutions. Yes, that's also true. Okay. So D option, let's just go to the option D. If the columns of A are linearly dependent, if the columns of A are linearly dependent, then Ax equal to B always have infinitely many solutions for every B. This is false, right? This is a nice option, but this is false. So what this option is saying that columns are linearly dependent, right? Then Ax equal to B always have infinitely many solutions. No, that is false. Why? Let me just tell you. See, so let me explain you option option D here. Okay. So they are saying, let's suppose you have some A. Okay. Let's suppose the A is having columns like 1, 2, 3. Second column is 2, 4, 6. I mean linearly dependent columns I'm writing. 3, let's suppose if you multiply with 3 here, then 3, 6, 9. Okay. Suppose this is A, right? Now there is some X which you have to find out, and there is some B. Okay. So B is, let's suppose, 1, 2, 5. Can you have solution for every B? Does this B have the solution? This B doesn't have any solution. Why? Because you, whatever you do, see, this is not 1, 2, 3. If it is a linear combination of 1, 2, 3, then only you have the solution. If this is not a linear combination of columns of B, A, then obviously you don't have the solution. So whatever X you write, there is no solution. So that's why there is no solution in this case. So that's why you will say infinitely many solutions. That's why it is false. Okay. So option D is false. Right. Now someone is asking, sir, how B equal to true? B is true. As columns are columns of linearly independent, then it may have unique or infinite solution. No, if columns are linearly independent, then it must be having infinite solution. See, if columns are linearly independent, okay, if columns are linearly independent, then must be having, sorry, it must be having unique solution. Okay, if columns are linearly independent, then it must be having the unique solution. Is there anything problem in my audio? Someone is saying, sir, your audio, you are not audible. Your voice is breaking. Okay, is my voice breaking? Let me know. Let me just fix if the internet, if that is something. Yes, sir, it is cracking. Okay. Okay. So in case of linearly independent, it is always a unique solution. So that's why B is true. Independent. In that case, it is always a unique solution. Okay. Someone is asking, sir, if we consider that A has m linearly independent vectors, after that the columns of A are linearly dependent because of some extra vectors, then the option D, can it be true? Yes, it can be true in some cases. Yes, that's a good observation. I was about to come at that observation. So basically, D is false if we talk about in general. But can there be infinitely many solutions? Yes, obviously. Like suppose that consider the case that, see, in this case there are no solution. Okay, there are no solution. But consider the case that this is 1 to 3. If this is 1 to 3, yes, there are infinitely many solutions, right? There are infinitely many solutions. Why? Because you can have 100 as one solution, right? Okay, you can have for example, 100 is one solution, 0 1 by 2 0 is another solution. Okay, you can have many other solutions. 0 0 0 1 by 3 is another solution. Okay, and there are many other solutions using the linear combination of these three. Okay, so there are many solutions, and infinitely many solutions will exist. So in this case, if the columns are linearly dependent, then either there are infinitely many solutions or there are no solutions, right? So let me ask you something like this. Tell me if this is true or false. Okay, suppose if I ask you that if A has linearly dependent, LD means linearly dependent, okay, columns. Okay, then then either, I mean, I'm asking for Ax equal to B. Okay, Ax equal to B has either infinite solutions or unique solutions. Is this true or false? Tell me. Sorry, either I have infinite solutions or let me ask for no solutions. Okay, instead of unique, let me ask for no solutions. So this is definitely true. Okay, this is true, right? So see, what we will be doing whenever we are writing any question, okay, we will be writing the question, and on the next page, okay, I will create the duplicate page of this, and on the next page I will be writing the solution. Okay, so there are like two different pages, and I won't be writing the solution on the same page. The reason is that suppose after some time, okay, you revise, and at that point in time you don't want to see the solution directly, so there should be a slide or there should be a page where there is no solution, and once you move further, then there is a solution. Okay, so for this reason there is a duplicate page. Okay, so since there are like first introductory classes, so that's why I'm telling you the reason why we are doing so. Okay, because over the time people have appreciated this, then I think this is a good idea. Okay. So someone is asking, how come no solution in linearly dependent columns? It depends if B is not a linear combination of columns of A. See, just like this, just like this. See here, there is no solution. Okay, there is no solution in linearly dependent columns. Understood? Here the columns are linearly dependent. Still no solution. So I can say no solution. And what about infinitely many solutions? Suppose if I write something like this, then in that case there will be infinitely many solutions. Okay. Then in that case there will be infinitely. So either no solutions or infinitely many solutions. So this is the case where infinitely many solutions. Understood? Yes, it depends on B. B must be linear combination of columns of A. If B is not a linear combination of columns of A, then there is no solution. Okay, like this. Okay, here no solution. Understood? Okay. So basically the question is asking for every B, right? Instead of following, I mean, which of the following Statement correctly describe the possible number of solutions. So someone was asking something like every v or something. So where is, yeah, so for every v, so for every v you should be having infinitely many solutions. So that is, since that is not there, I mean for some v there is so they are saying, yeah, for some v there is no solution also. So yes, infinitely many solutions or no solutions. So suppose in option D, if I write for every v infinitely many solutions or no solutions, then this is true. In that case, this option is true. Okay, in that case this option is true. Understood? If they say or no solutions. Okay, because infinitely many solutions always exist, doesn't it is not necessary. Now let's solve this question. This question has been asked in gate ec 2007. Okay, since this question was having some terms like spanned and all, which currently you might not have studied. Okay, you might study later on if you are from gate da. So I mean, let's not worry about it like span. So I have just converted this question in the simpler words. So the same question, let's just solve this question. So they are saying it is given that x1 x2 xm are m non-zero vectors and every pair of them is orthogonal. Orthogonal means perpendicular, which means that they are basically having the 90-degree angle, which means the x1 vector and x2 vector are having 90-degree angle. Similarly, x3 vector is having 90-degree angle with x1 x2 and so on and so forth. Obviously I cannot draw m dimensional space here. Okay, so that's why I'm just telling you with the two vectors, but all of them are perpendicular to each other. Now they are saying it is very simple question. Now they are saying consider the following 2m vectors. Okay, so there are like m vectors like this and m more vectors with the minus sign. This question has been asked in gate ec 2007. What is the maximum number of linearly independent vectors among these above 2m vectors? So these are the 2m vectors. What is the maximum number of linearly independent vectors you can choose? See, if they are perpendicular to each other, okay, if they are perpendicular to each other, in that case they are definitely linearly independent. So they are saying perpendicular, then obviously they are linearly independent. All of these are linearly independent, right? Then obviously you will be choosing, if you have to choose the maximum number of linearly independent, then you will be choosing all of this. Now the question is that can you put one more or maybe even more vectors than these? See, if the vectors, okay, let's suppose v1, v2, v3, if these vectors are perpendicular to each other, okay, in that case they must be linearly independent also. Just like this, see, just consider for the simpler example. See, these are the convenient vectors. Do you remember these vectors? Anyone remember these vectors? Right, these are the convenient vectors that we have. Now this is like x-axis, y-axis and z-axis, just like that, right? X-axis, y-axis and z-axis. Okay, so now here these vectors are these vectors perpendicular to each other? Yes. If you just take the dot product, I mean if you don't know currently what is the dot product and all, that's fine. But basically you just need to multiply these two vectors, right? A transpose b or something like this. And yes, they are perpendicular to each other and they are linearly independent also. I mean, they're if they're perpendicular, then they must be linearly independent. But this direction is not true, which means if the vectors v1, v2, v3 are linearly independent, okay, in that case they are perpendicular. This is false, okay, or orthogonal. Basically, the term that we use is orthogonal. Okay, so in that case, this is a false claim, right? But this way is a true. This way is, which means if they are perpendicular, then they will be linearly independent. So can you solve this question now? So basically, can you include any more vectors? Obviously no, because the moment you include minus x1, it is directly dependent on x1. But you want all the vectors to be linearly independent vectors. So that's why, what is the answer? C is the correct answer here, right? C is the correct answer. Okay. So some of the students are not getting this. Don't worry. You can do one thing. Okay, you can do one thing. Uh, Anyone here can mathematically prove this? If the vectors v1, v2, v3 are perpendicular to each other, okay, which means I want to prove that c1 v1 plus c2 v2 plus c3 v3, okay, equal to 0. This has this has only trivial solution. Okay, this has only trivial solution if v1, v2, v3 are orthogonal. Okay, can anyone here mathematically prove this? So, see, this is just an optional discussion. I mean, you don't have to do all of this, just an optional discussion. Basically, geometrically, you can understand if you don't want to understand mathematically. So this is just optional discussion. Okay. See, if the two vectors are perpendicular to each other, which means they are having 90-degree angle, then there is no influence of one vector on another vector. Okay. Have you in physics, if you have studied physics, I mean, you don't have to study physics to understand linear algebra. Just I'm asking, have you studied like x? If you do the component of this, then this is if this is theta, then this is x cos theta, something like this. Have you studied these things? Probably, right? X cos theta, x sin theta, something like this. ओके, तो वैसे समझ सकते हो लाइक इसका इधर प्रोजेक्शन और इसका इधर बेसिकली कंपोनेंट जीरो है. बेसिकली देयर इज नो इन्फ्लुएंस ऑफ ईच अदर ऑन एनी डायरेक्शन, सो दैट्स व्हाई दे आर लीनियरली इंडिपेंडेंट. बट ऑप्शनली आई एम टेलिंग यू वेरी क्विकली जस्ट इन 1 minute. Okay, you can mathematically also prove it. How? You can say, suppose there exists some non-trivial c. Okay, so basically how you can prove it, this is a big optional proof. Okay. So basically you can say, suppose there exists c1 not equal to 0. Okay, so I mean some c. Okay, well, let's suppose c1, okay, not equal to 0. Then you can write v1 c1 v1 as minus of c2 v2 plus c3 v3, and then you can divide by c1. Okay, that's fine. Now what you can do, you can multiply by c1, you can multiply by v1 both side. If you multiply by v1 both side, then what will happen? Multiply by b1 both side, this will be c1, and b1 and b1, I mean b1 transpose whatever you consider. Okay, so it will be b1 square basically. Okay, b1 square, it will be multiplying by b1, since they are orthogonal, then multiplying by b1 will be 0 here and will be 0 plus 0 basically, right? So which means it is 0 only. So since this is a non-zero vector, so so that's why you can send it in the zero. So c1 will be 0 from here. So basically, if you are saying that okay, c1 is not equal to 0, then c1 has to be 0. Anyway, so basically this is contradiction, which means c1 cannot be 0. Anyway, so don't have to worry too much. Okay, just an optional thing I'm saying. So you can remember like this, that if they're perpendicular, then they must be linearly independent. Okay. So if they're perpendicular or orthogonal vectors, then they must be linearly independent. Okay, this is important. Okay. Now let's see this question. This question has been asked in 2007 only, gate instrumentation. Okay. Let's see this question. By the way, there are some other probably proofs that one of the student has suggested. So if you want, you can look at this proof later on. Okay. So Sujal has suggested some proof. So if you want, you can look at this proof later on. Let me just write this proof also. Now let's see this question. So this question has been asked in Gate Instrumentation 2007. Okay. Let A be n cross n real matrix such that A square equal to I and by be n dimensional vector. Then the linear system of equation Ax equal to y has. So basically they are saying that A square equal to I is given. Okay. And then they are saying y is some vector. I mean, instead of y, we generally used to have b here. So you, if you want, if you're comfortable, you can write b. It doesn't matter. Okay. If you want, you can write b. It is like as good as b. Okay. So they are saying that ax equal to b. They are asking about ax equal to b. Okay. So they are asking about ax equal to b has some solution, no solution, unique solution, or something like this, right? But they have given that a square is I. So see, in linear algebra questions, you with the practice it will come, but sometimes you have to use some kind of jugad or some kind of things. I mean, they might not come directly. Okay. So for example, if a square equal to I is given, so what you can do, they are asking about ax equal to b, right? They are asking about ax equal to b, and it is given that I means identity matrix, right? Identity matrix. Okay. Now, what you can do, you can make this a square, you can multiply by a both side, and it will be like this a square, x equal to ab, right? Now, since a square is I, okay, so that's why it is I into x, which means x. Can I directly write x? Yes, I is always identity. Okay, I mean, they might have given this, but even if they do not give, okay, they have not given it. Even if they do, I is always identity. I mean, until unless they write something else. I is identity matrix. Okay. So you multiply by a both side, it will be a square x equal to ab. A square is I, so it will be I into x equal to ab. So it will be x equal to ab, right? So basically, you just got your x, which is ab, isn't it? We wanted to get x. So do you have the solution for x equal to b? Solution means do you have x? Yes, we have x, which is AB. Okay, whatever it is, it doesn't matter. Whatever it is, right? It is just a black box for you. Just a black box. But is this unique? If you multiply a vector and a matrix, then will it be unique or there could be multiple possibilities? Tell me. Is this a unique x or there are multiple possibilities? This is unique, right? Obviously, there this is unique. So basically, whatever this black box is doesn't matter. So let me just write it as a black box. Doesn't matter. You can say that x is unique. Okay, x is the solution. Okay, x is the solution we are looking for, and x is unique. So you can say that uh, that b is the correct answer here. Okay, b is the correct answer. Okay, some students are asking why unique. Just tell me, if you multiply, what is x? If you multiply, this is ab. If you multiply a matrix and a vector, is this a possibility that you will be getting multiple answers? Will you be getting multiple answers from this multiplication? No, right? You will be getting deterministic and a single answer. So this multiplication leads to a single answer, isn't it? So you can say this multiplication leads to single answer, right? So that's why x is unique. Understood? Okay. So what is the answer here? Answer is B, unique solution. See here, it was the original question, but on the next page, okay, on the next page we have just annotated it. I marked the answer. So whenever you're coming for the revision, you will be first seeing this, and then if you want to see the solution, you will go to the next page to see the solution, right? Okay. So some students are talking about the inverse. Yes, you can use the inverse thing, but I think currently, based on the lectures that we have discussed till now, we have not used the inverse word. So inverse, I am not using the concept, but yes, you can use the inverse thing if you already know. Okay. More than one, but finitely many. It is never possible. Okay, it is never possible to have finitely many. I mean, either there is no solution, or there is unique solution. Okay, or there is an infinite solution. There cannot be finite solutions. Okay, there cannot be finite solutions, just like five solutions. Okay, it can never happen, because if there are even two solutions, then the linear combination of those two will also be the solution. Okay, then there will be like many solutions. So basically, either the three possibilities will be there. Finite solutions is not a possibility. This is never a possibility. Okay. Okay, so option D is saying infinitely many independent solutions. It is also never possible. Infinite, if there are infinitely many solutions, then obviously they have to be dependent. I mean, independently you cannot have. I mean, then you have to have R infinity, right? I mean, there is nothing called R infinity. So you cannot have like something like R infinity. Okay, I mean, if there are infinitely many independent vectors, which means that is possible only in R infinity. Okay. Okay. So someone is saying that from this directly can we say that there will be unique solution, because uh, this matrix is linearly independent or something like this. No, like basically there is no concept like this matrix is linearly independent. I mean, matrix doesn't have linearly independent or dependent. Yes, there are vectors in it which are linearly independent vectors, but it doesn't mean that. I mean, just like this we can say. Okay, I mean you can use the concept of inverse and all, but see, your line actually is very confusing. Also, the line that you have written is something like this. Okay, so okay. Anyway, now let's just move to the next question. So this question has been asked in GATE Mathematics 2007 again. Okay. So this question was having some dimension or something like this. So basically, I was just converting this question to the easy language. Okay, so that we can understand this. Right. So the question is same. Now let's just see that what they are saying. They are saying let A be this. It is given that the set of row vectors of A is linearly dependent. So they are saying that these vectors are linearly dependent. It is given. Okay. I mean, these two are linearly independent, that is for sure. For two vectors, it is easy to check, right? Suppose for two vectors, you have to check whether these two vectors are linearly dependent or independent, then what will you do? These are, let's suppose, two vectors. If you have to check, check if these are linearly dependent, then what you have to do? Yes, you can use it using the scalar multiplication. Yes, great. So I think everyone has given the correct answer. Okay, so we can do using the scalar multiplication. Okay, so now suppose now suppose if we have to check whether these two are linearly dependent or not. Okay, I mean these two first two rows. If I have to check, then you can easily see that they are linearly independent rows. Right? Let's just see what this question is asking. It is given that they are saying that these rows are linearly dependent. If these rows are linearly dependent, then what does this mean? Since these two are linearly independent, this must be depending on these two, right? Which means I'm writing in the column form, which is fine. I mean, just for the writing it. So, which means this must be dependent. I mean, something like C1, C2, or whatever you write. If these three are linearly dependent, if these two are linearly independent, to make the linear dependency, it means that this must be linearly dependent, right? Okay. V is a set of all vectors of x, y, z satisfy this condition. What is the maximum number of linearly independent vectors that can be chosen from the set V? Okay, this is very interesting, and actually, this particular question, okay, this particular question, uh, mm, you will be able to understand this bit better after few more lectures. Okay, once you understand the system of linear equations, okay, you will be able to understand this a bit better. But currently, also, I thought that we can solve this question. That's why I'm taking this question. So let me explain you that what this question is saying. This is saying let's make a set. Okay, let's make a set V which is having all x, y, z. For example, if C1 is 0 and C2 is 1, can you tell me what this V will be having? See, for all the values of C1, C2, just tell me. If C1 is, this will be 2 to 3, right? I mean, if C1 is 0 and C2 is 1. Okay. Similarly, can you tell me if C1 is 1 and C2 is 0, then what will this vector? What will this be containing? This is all the possible values of x, y, z. This will be containing 1, 1, 1, isn't it? Similarly, can you tell me if C1 is, let's suppose, some value 1 and C2 is also 1. In that case, what this will be containing? This will be containing 3, 3 and 4, right? And similarly, and so forth, right? I mean, you can have C1, C2, some value C1 equal to 5, C2 equal to 6, something like this. And it will be containing some linear combination of these two vectors. Okay, some linear combination of these two vectors. Now they're asking from this V, how many maximum number of linearly independent, so there are many, infinitely many vectors depending on values of c1 c2. Okay, see, you can put any value of c1 c2. For example, if xyz is this, okay, xyz is c1 into 111 plus c2 into 223. Then, if you ask me what are the possible values of vectors that can be there in this set, there are infinitely many vectors in this set, right? There are infinitely many vectors. They're asking out of those infinite vectors, infinitely many vectors, how many maximum linearly independent vectors you can choose? Okay. Maximum linearly independent vectors we can choose. This is what they're asking, right? Okay. See here that somewhere you will be having, whenever c1 is 1 and c2 is 0, you will be having 1 1 1 2 2 2 2 3, and these are linearly independent. That's what you already know, right? These are linearly independent. The two I mean, two linearly independent you can definitely choose. Okay, but the answer is that can you choose more than two? Okay, two you can definitely choose. You will choose this, you will choose this, but can you choose more than two? See, whatever you next choose, it will be a linear combination of this and this only. It cannot be linearly independent, right? Whatever you next choose, it cannot be linearly independent. That's what you need to understand, right? So you will say that maximum you will be choosing two vectors, right? Maximum you will be choosing two vectors. Okay. So some students are saying it is same like Walmart question. So those who have not watched the video, like there is one question there they were asking about the and that question was related to one interview question which was asked to me in Walmart company. Okay. Anyway, so okay. So is this fine to everyone? No. So someone is saying that I was checking the dependency between the columns, but you are checking the dependency between the rows. See, they are saying the set of row vectors, okay, of A is linearly independent, and yes, in linear algebra, it is sometimes it is about the observation also, okay, and it will come with the practice. It will come with the practice also, okay. So they're saying set of row vectors, but yeah, even if they do not say something like this, then it will come with the practice, okay. Then what you should be, how you should be solving this question. Okay, because this is about the observation. So what is the correct answer here? The answer is C. Okay, it was a good question. I think, right? It was a good question. Little tough one also, but yes, this was a good question. Okay. Now let's solve this question. This question has been asking gate engineering sciences, something like that. XE, I think engineering sciences. Okay, there is one gate examination called engineering, um, engineering sciences, right? Okay, engineering sciences, something like this. And for that code is XE. Okay, something like this. Okay. Anyway, let's just read this question. What this question is saying? They are saying let ax equal to b, let ax equal to be the system of m linear equations in m n unknowns with m is less than n. So let's just take it as 2. Let's just take this as 3. So which means you have m linear equations. So 2 equations uh, and 3 unknowns. So which means 2 by 3 column, right? 2 by 3. Okay. Now they're asking the system has, so A is 2 by 3, 2 rows and 3 columns. Okay, one column, second column, and 3 column. Now the system has n minus m solutions, either 0 or infinitely many solutions. See, since every vector is in R2, right? Every vector is in R2. Now there must be linearly dependent vectors. These vectors must be linearly dependent because there are 3 vectors. Okay, is this fine to everyone? Can you tell me what was your thought process? Instead of just telling me the answer, do anyone wants to tell me the thought process? You can raise the hand and I will unmute you. Okay, you can raise the hand and I will unmute you. Okay, yes, Gautam, do you want to tell?
Yes, sir.
Yeah, yeah, please tell me what was the thought process.
So we can say that m is less than n. Then the vectors, then the column vectors will be in Rn dimension.
हाँ,
I
2
mean,
और 3 में आप समझा सकते हो क्या, लाइक 2 और 3 का एग्जांपल लेके?
हाँ हाँ सर। अगर 2 क्रॉस 3 का मैट्रिक्स होगा तो कॉलम वेक्टर्स R2 में ही रहेंगे, हर एक
हाँ,
कॉलम
हाँ।
वेक्टर। एंड हर एक कॉलम वेक्टर R2 में ही रहेगा, बट देयर विल बी मिनिमम 3 कॉलम वेक्टर्स मिनिमम,
हुँ, हुँ।
है ना। तो वो ऑलवेज लिनियरली डिपेंडेंट सेट ही होगा कि R2 में दो ही लिनियरली इंडिपेंडेंट वेक्टर्स रह सकते हैं, उससे ज्यादा नहीं रह सकते। तो
राइट,
ऑलवेज
राइट।
लिनियरली डिपेंडेंट ही होगा। और अगर 2 लिनियरली इंडिपेंडेंट वेक्टर्स हुए तो वी विल गेट सोल्यूशन, मतलब हम हर एक बी के लिए सोल्यूशन पा जाएंगे कि वो R2 का वेक्टर स्पेस फिल कर देगा। बट अगर हो भी सकता है कि एक लिनियरली इंडिपेंडेंट वेक्टर हुआ, तो इस केस में हो सकता है कि सोल्यूशन ना भी मिले। तो नो
राइट,
सोल्यूशन
राइट।
और इनफाइनाइटली मेनी सॉल्यूशंस।
Yes, yes, right. That's correct. Okay, thank you, Gautam.
थैंक यू सर।
Okay. So basically, what he's saying that if you are having 2 cross 3 matrix, right, where you are having 3 columns, every column is in R2, right? Every column is in R2. Now, in that case, whatever B you have, either this B is a linear combination of these columns or not a linear combination of these columns. I mean, this is possible that B is completely different, right? Let's suppose this is 1 2 1 2 and B is 1 3. In that case, no solution, right? In that case, no solution. Understood? But there is a possibility. Okay, there is a possibility that there is a solution also. For example, sorry. For example, let me take. So currently there is no solution, right? But there is a possibility that there could be solutions also. Suppose, suppose this is 1 2 only, or maybe let me just change the value so that you don't get confused. Suppose this is 1 2 and this is, let's suppose, 4 5, and this is anything 1 3. Okay, suppose this is 1 2 only. Can there be a solution? Yes, there is a solution, right? Yes, there is solution. So there is a solution, and since these are linearly dependent, there will always a linearly dependent. Okay, always the here also, here also. Okay, because there are 3 vectors. Since they are always linearly dependent, Then if there is a solution, yes, solution is there, but solution cannot be unique because these are linearly dependent. So that's why solution, but infinitely many. Okay. So that's why you can say either no solution if B is not in the space, column space, or in other words, if B is basically not the linear combination of these vectors, then there is no solution. But if B is linear combination of these columns, in that case there cannot be unique. There will be infinity. So either no solution, zero, either no solution or infinitely many solutions. So B is the correct answer here. Okay. Okay. Now let's just go to the next question. I hope you understood this question. Yes, there are many other ways to solve linear algebra questions. So Aditya is asking, can we solve this question with the concept of pivot variable? Yes, you can definitely solve. Okay. Yes, there are many other ways to solve these questions. In linear algebra, there are always many ways. Okay, to solve a single question. But currently, I am solving based on what we have studied till lecture 4. Okay. So yeah, there are many other solutions proposed, but yeah. Now let's solve this question. This question has been asked in GATE EC 2008. So they are saying the system of linear equations, okay, has. See, this is easy question, just observation kind of question. If you notice, this is basically this is twice of this. I mean, both equations are like kind of linearly dependent. But if you notice that this is not 12. I mean, this is 7. If this is 12, then this is good. I mean, both are good. But since this is 7, it means this equation and this equation are basically completely different from each other. I mean, if you just rewrite this equation, just divide by 2, 2x plus y equal to 7 by 2. It is saying 2x plus y is 7 by 2. This is saying 2x plus y is 6. So since there is inconsistency, okay, I mean, both are not agreeing, right? I mean, either they're different. If they're not different, if they're same, they have to be exactly same. Okay, since both are not agreeing, so you can say there cannot be any solution because there cannot be x and y which are giving you 6 also and 7 by 2 also. Obviously, it is not possible, right? So that's why with the observation only you can say this is no solution. Okay, just a simple question, but yeah. Is this fine to everyone? That question has been asked in GATE EC 2008. Yes, there will be many more live classes in the linear algebra. Okay, just to keep you consistent. Just to keep you consistent. Okay, timing will be 8 p.m. only. Okay, if there is change in timing, we will tell you, but timing will be mostly 8 p.m. Okay, so I'm solving these simple questions just to keep you consistent, so that you can come prepared. Okay, and you can solve live these questions. So Shreya is asking, it is not mentioned that when to attempt weekly quizzes. We will mention in the schedule itself. Okay, we will whenever you have to attend the weekly quiz, we will mention in the schedule itself. Okay. So this question has been asked in aerospace engineering. AE means aerospace. Okay. The linear system of equations x equal to b. So if you notice, this is like kind of twice of this, right? I mean, both are linearly dependent columns, right? Both are linearly dependent columns. And B is something very different. B is not 1, 2. In that case, what you can say? If this is 1, 2, then only it is, I mean, some multiplication of 1, 2, then only there could be the solution, but it is very different. So as you know, right? As you know, see here that if you are having B, which is not in the linear combination of columns of A, B is very different, not a linear combination of columns of A, then there cannot be any solution. So this is no solution, you can say, right? So here you can say there is no solution. Okay. So based on the lecture, first 3 4 lectures, right? We have taken these questions. Okay, so we will be solving many more gate questions which have been asked in different branches, just to give you different flavors. Okay, currently I was only able to find these questions which were relevant to the lectures. Okay, maybe there are more questions. I will be picking more questions also. I went till I think gate 2015 or something. Okay, So from 2007 to 15, I have bent. I don't know why, but there were only few questions. So I have checked all the branches, but these are the only questions which I was able to find. Obviously, there might be more questions after 2015. I will be basically collecting all the questions and then we will be solving in the next live session. Okay. So this is all for this session. If you have any doubt, you can definitely ask me. Someone is asking, Gautam is asking, sir, I have done doubt in the question from the future lectures. Okay. Yeah, you can just ask here or you can ask in the Telegram. You can just DM me if you want. Okay. Anything is fine. Gate overflow, I don't know if gate overflow has all the math questions from all the branches. I think gate overflow doesn't have. For many branches it has, but not for all the branches. Okay. Okay, so one of the student is saying, sir, I have doubt in linearly independent question. You can ask your doubt. You can write, or if you want, you can speak. So by the way, let me do one thing. Let me just stop the recording. If there is something that need to be added, I will just resume the recording, and let me stop the recording so that it is for the shorter duration for the future experience. So thank you everyone. And if there is any doubt, let me just solve. If there is something which I think should be included in the recording, I will just resume the recording. Okay. So thank you everyone for watching the lecture. Thank you so much. Yes, Naman.
Sir, I wanted to thank you because recently I was enrolled in an NPTEL course on large language models. So, in the week one lectures, they discussed about semantics, morphology, and all these things. So, in there were topics like decompositional semantics and all that. So, when I started the first lecture of the course, it discussed all the applications of linear algebra. So, there you gave that example of king minus man plus woman equals queen, like that. So,
Yes, yes.
I mean, it connected to that decompositional semantics that I had studied. So, like, this subject is becoming really interesting to me, and like, it is totally application. Sir, I did not know that mathematics has so much of application in the industry and everywhere. So now I'm really inquisitive about this subject, sir. After that,
Yeah, that's really good to see that you're finding LLMs interesting. LLM is future also. So chat GPT and everything is basically based on those courses, LLM courses. And अगर आप अभी उनको अच्छे से करोगे तो definitely मतलब आपको बाद में like you will be finding very easy to get into top companies. Yes, linear algebra तो काफ़ी basic है और ये basic important भी है तो ये तो आना ही चाहिए. But हाँ, that's good to know. Thank you Naman for sharing your experience.
thank you, sir. It was really lovely, sir. Thank you, sir.
Thank you. Okay, so Raj, you want to ask something? So thank you everyone. Thank you for asking the doubts. It was a nice class, a small class but a nice class. Okay. So thank you everyone. Good night. Take care. If there is any doubt, you can tag me on the Telegram group or you can just DM me. Yes, the recordings will be available for this class. Okay, for every class, whether it is technical, non-technical, for every sessions, there will be the recording. Okay. Thank you.